The first time I saw a real photo of a black hole, I honestly didn't believe it was real. Because somewhere in our galaxy, right now, there's a region of space where the laws of physics as we know them simply stop working. A place where gravity is so extreme that not even light, the fastest thing in the entire universe, can escape it. Scientists can observe this region from the outside in incredible detail, but they have never been able to see inside it. And the deeper researchers dig into what might actually be happening beyond that boundary, the stranger, and honestly, the more unsettling, the answers become. So stick with me, because by the end of this video, you're going to understand something most people never fully grasp about black holes, and one part of this story genuinely still gives physicists chills. Welcome to Deep Space Files. Before we go anywhere near the inside, let's clear something up, because a black hole isn't a hole in the way most people picture it. A black hole forms when an extremely massive star runs out of fuel and collapses in on itself. For most of a star's life, there's a constant tug-of-war happening inside it, gravity pulling matter inward, while the energy from nuclear fusion pushes outward, keeping everything stable. But once a massive enough star burns through its fuel, that outward pressure disappears, and gravity wins. Completely. The core collapses into an incredibly small, incredibly dense point, and what's left behind is a black hole. The boundary surrounding it is called the event horizon. Here's the part that surprises people. There's nothing physically there. No wall, no surface. It's simply the exact distance from the center at which the speed needed to escape exceeds the speed of light itself. Cross that line, and based on everything we currently understand about physics, there is no way back. Now let's actually imagine it. Picture yourself falling toward one of these things. As you got closer to the event horizon, gravity wouldn't pull on you evenly. The part of your body closer to the black hole would get pulled far more violently than the part farther away, stretching you out longer and longer while squeezing you inward from the sides. Physicists genuinely call this spaghettification. Yes, that's the real scientific term. For a smaller, stellar mass black hole, this would happen almost instantly and pretty brutally before you even reach the horizon. But for supermassive black holes, the kind sitting at the centers of galaxies, the stretching near the horizon is actually much gentler, meaning you could theoretically cross the horizon in one piece, at least for a little while longer. Here's where it gets stranger, though. According to Einstein, gravity slows down time itself. If someone were watching you fall in from a safe distance, you wouldn't just disappear. You'd appear to slow down more and more, freezing right at the edge of the horizon, fading and reddening until you simply vanish from view. But from your own perspective, time would feel completely normal. You'd cross the horizon and just keep going, with no sense that anything unusual had happened at all. According to general relativity, everything that falls into a black hole eventually gets crushed down into a single, infinitely dense point at the very center, the singularity. And this is genuinely the part where our physics just stops working. Density becomes infinite. Space and time, as concepts, stop functioning the way they do everywhere else in the universe. When physicists say the math breaks down, this is exactly what they mean. One of the most successful theories in scientific history just throws up its hands. Most physicists don't actually think an infinitely dense point is the real final answer. Most suspect our current theories are simply incomplete, that once someone finally merges general relativity with quantum mechanics into a full theory of quantum gravity, the singularity might turn out to be something completely different. So here's the honest truth, and I think this is the part people find most unsettling. Nobody currently knows for certain what's really at the center of a black hole. Nobody. That's not me being dramatic. That's the actual state of physics today. If this is blowing your mind a little bit, same here, honestly. Go ahead and hit like right now. It genuinely helps this channel keep making videos like this. Okay, back to it, because it's about to get even weirder. Here's a question that's kept physicists up at night for decades. When something falls into a black hole, what actually happens to the information that made it what it was? Quantum mechanics says information should never truly be destroyed, Even if something gets transformed, its underlying information should still exist somewhere. But general relativity says, once something crosses the horizon and hits the singularity, that information is gone. Completely. Sealed off from the universe forever. These two ideas flatly contradict each other. It's called the black hole information paradox, and it sits right at the center of one of the biggest unsolved problems in all of science, unifying quantum mechanics with general relativity. In the 1970s, physicist Stephen Hawking dropped a bombshell on the scientific world. Black holes aren't entirely black. Due to quantum effects near the event horizon, black holes should very slowly leak a faint form of radiation, now called Hawking radiation. Over almost incomprehensibly long timescales, this causes black holes to lose mass and theoretically eventually evaporate completely. For most black holes, this process would take far longer than the current age of the universe, so it's not something we'll ever actually witness. But it completely changed how physicists think about these objects. Black holes aren't necessarily permanent. They might just be very, very slow processes. Okay, this is the part where the science shifts from established theory into genuine speculation, and honestly, it's my favorite part of this whole topic. Some theoretical models suggest the extreme conditions inside a black hole could, mathematically, connect to something called a wormhole, a hypothetical shortcut potentially linking one region of the universe to another, or maybe even to a separate universe entirely. There's also the idea of a white hole, a mathematical mirror image of a black hole that endlessly expels matter instead of consuming it. I want to be upfront with you here. None of this has any observational evidence behind it. Not one shred. These are mathematically interesting possibilities that fall out of certain interpretations of general relativity, not confirmed predictions. No telescope, no spacecraft has ever detected anything resembling a wormhole or a white hole. For now, this stuff lives purely in theoretical physics. Fascinating, but completely unproven. Despite everything we still don't know, here's something incredible we have actually confirmed. In 2019, the Event Horizon Telescope team released the first ever direct image of a black hole silhouette, the supermassive black hole at the center of galaxy M87. In 2022, they followed it up with an image of Sagittarius A star, the supermassive black hole sitting at the very center of our own Milky Way. Neither image shows the black hole itself. By definition, that's impossible. What you're actually seeing is the glowing ring of superheated matter swirling around the event horizon, silhouetting the black hole's shadow at the center. It's one of the great achievements of modern astrophysics. Real, direct visual proof of something theorized for over a century. So, what's actually hiding inside a black hole? The honest answer is, we don't fully know. And I actually love that about this topic because that's not science failing. That's science being honest about where the frontier still is. We understand the event horizon. We understand spaghettification, time dilation, Hawking radiation. We've even captured real images of the boundaries surrounding these objects. But the singularity, the actual center, still a genuine mystery. Maybe a future breakthrough in quantum gravity finally cracks it open. Or maybe black holes keep their secrets a little longer, staying one of the last true unknowns in a universe we're only just beginning to understand. If you want to go even deeper, I'm covering wormholes, the ones we just talked about, in a full video very soon, so make sure you're subscribed so you don't miss it. Until next time, this is Deep Space Files. Don't forget to subscribe, and I'll see you in the next one.